Hi, this is Mrs. Vaughn. This video is for my geometry class. This is going to cover the homework assignment for section 2.8. I have made some modifications to the original homework assignment that I handed out last week when we thought we'd have a virtual day on Monday. And because some of them are for constructions, and I'd rather focus on the proofs and actually solving the distances and midpoints and stuff algebraically instead of going back to the construction pieces. So just kind of follow along as we go. This does cover 2 days worth of lessons. So this will kind of Monday and Tuesday. So take your time. It is a lot, but I'm going to try to move as fast as I can. Okay, so for number one, they've given us a number line from -15 to 15 and measured some points on there with their coordinates. And so we need to use that information along with our distance formula to solve the given or the requested distances. So we need to solve line segment FC, what that length is, HG and BD. So you should have this close by. If not, just make sure you've got a note card or something made for it. But your distance formula is at the very beginning of section 2.8, the top of page 97, I believe. But the distance of any line segment, we'll call it AB, is the absolute value of the coordinate at point A minus the coordinate at point B. Absolute value, of course, eliminates any issues for which point you start first. It's just measuring the length from one point to another, and length is always positive, whether you're moving left to right or right to left. So when we plug that in for A, we get line segment FC is equal to the absolute value of the coordinate at point F minus the coordinate at point C. So when we look at our number line, we see that the coordinate at F is 4 minus the coordinate at C, which is -6. Remember to keep your absolute value is considered a grouping symbol when it comes to order of operation. So you solve inside the absolute value first, simplify 4 minus a negative number is 4 plus 6, and that is equal to the absolute value of 10, which is just 10. Okay. And if you want, go to your number line. Start at F, go to C. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you can see how that formula works every time, even if you're working with very large numbers and you're not actually wanting to have to count on a number line. Okay, so from point H to point G, line segment HG is the absolute value of coordinate at H minus the coordinate at G. Remember, we represent coordinates, the value of the coordinate as a lowercase number. The point is an uppercase number. So H is 10, the absolute value of 10 minus G, which is 6. So that's the absolute value of 4, which is 4. All right, last one. Line segment BD is equal to the absolute value of coordinate B, which is -9, minus D, which is -2. So this is the absolute value of -9 plus 2, which is the absolute value of -7. So here's where you see the absolute value comes in handy, and our distance is 7. Okay. 3 and 4 are asking us to find the coordinate of the midpoint of some of these line segments. So this is where your midpoint formula comes in. The midpoint is equal to, it's an average, it's the right in the middle between the two. So you take coordinate A and you add it to coordinate B, and then you divide that total, that sum, by 2, which is just an average. So if we're looking for FH, the midpoint of FH, I'm going to write that. So midpoint equals point F is 4 plus H, which is 10 divided by 2. So we'll check myself. Why? Come on. Yeah, okay. 4 plus 2 is 14 divided by 2. So the midpoint falls at coordinate, the coordinate 7. All right, so Moving on, oh, and then 5. So number 4, find the coordinate of the midpoint of CE. So the midpoint is C, which is -6, plus E, which is 0, divided by 2. Well, we know any number plus 0 is that number. So -6 divided by 2 is -3. That is where the midpoint of line segment CE falls. So now, which point is the midpoint of CG? This is where your definitions and your syntax becomes really important. When it asks what point is the midpoint, it's asking for the name, not the coordinate. Let me show you what I'm talking about. So first, let's use our midpoint formula to find out what the coordinate is. So C is -6 and G is +6. So C plus G divided by 2 is -6 plus 6 divided by 2. We know any number minus itself is 0, and any number divided into 0 is 0. So the coordinate is 0, but that's not what we're asking for. We're asking for the point. So go back to your number line, and you can see that the point at coordinate 0 is point E. So your answer here is E. Okay, so let's move into true or false section, number 8 and number 9. So number 8 says that if line segment AX is equal in length to line segment XB, then X is the midpoint of AB. You may think this is true. However, there's a very crucial piece of information that's missing from this. You also must be given that point X is between point A and point B in order for X to be the midpoint. Because they don't give you that information here, this is false. I'll show you an example of what I'm talking about here in a minute. Let's look at number 9 first. So number 9 says that if line segment SX is equal to half the length of line segment SR, then X is the midpoint of SR. Again, this is missing the given information that X falls between S and R. So this is actually false. Let's look at number 8 really quick. So if I had a triangle and it was labeled A, X, B, then I may say that yes, line segment AX is the same length as line segment XB, but X is not the midpoint because they don't fall on the same line. X just happens to be the intersection of those two line segments, raised lines, whatever. So that's why you have to be given that X not only is the same distance from A and B, but that it also is between A and B. That's that definition of between. SX is equal to half of SR. Again, you could have this as like an obtuse angled triangle, right? So if SX, that length is about half the length of XR. So SX is equal to half SR, but X is still not the midpoint because it's part of a triangle. They're not on the same line. You must state that X exists between S and R in order for that statement to be true, that it is the midpoint. All right, so moving on to number 16. So for number 16, we're doing what we did on our worksheet last week. Find the length of line segment AB if you're given that X is the midpoint of AB and the line segment AX is equal to 4. I like diagrams, like my visual aids. So I have line segment AB, and I'm told that X is the midpoint. I'm also told that AX is equal to 4, and I'm asked to find the length of AB. I don't want to use X. I'm just going to use a question mark. All right, so a couple of things that a midpoint tells us. First off, a midpoint tells us that X is between A and B, but that's not really what we need right now. What we need is to know that also line segment AX is equal to line segment XB. Also, the full line segment AB is equal to the length of AX plus the length of XB. So first off, AX equals XB. If AX equals 4, that also means that XB equals 4. And then when we've now created a value for both line segment AX and line segment XB. So we can plug that into this formula and we get that line segment AB is equal to AX, which is 4, plus XB, which is 4, which means that line segment AB is 8. Okay. All right, number 19. Okay, so given the coordinate of M, which I've put just below it, M equals -6, and the length of line segment MB, which is equal to 3, find the coordinates of A and B. Okay, so they have stated that M is the midpoint of AB. So again, that gives us some information that tells us that, I'll find myself here. So AM is equal to MB. Also, AB is equal to the smaller segments, AM plus AB. See diagram above, but replace the X with the M. And then you can use that to plus what they've given, the midpoint and one of the endpoints, to find the coordinates of the two endpoints. So when we're finding coordinates and we're given the midpoint, that means that we can use, we're finding the distance. No, yes, we're using the distance formula to define our coordinates. So distance formula, in this case, that's the line segment AB is equal to the absolute value of A minus B. This is MB. So the all right, so that formula in our case says that MB, that's our length, excuse me, is equal to point M minus point B. Now, when you are using the formula to calculate your endpoints, anytime you have absolute value, you must have a length that's going to the left of the midpoint and a length that's going to the right of the midpoint. So it's the length of the distance formula that you must have a positive version and a negative version. So when we do that, we end up, they gave us MB and B equals 3. So with a positive length, 3 equals the midpoint, which is -6, minus B. Nope, don't need absolute value. The point of doing this is to eliminate the absolute value. Excuse me. But then we also need to do this with negative length. So moving down the number line from the midpoint to find the other end point. So -3 equals -6 minus B. All right, so now it's just basic algebra. We isolate our variable by using the addition property of equality to add 6 to both sides. That leaves a -B on the right side, and 3 plus 6 is 9. And then we do it here. We end up with -B equals -3 plus 6, which is +3. All right, but you cannot leave a variable negative. That's like the variable times -1. So again, use the multiplication property of equality to divide both sides by -1. And that changes it to the variable, which is B. 9 divided by -1 is -9. 3 divided by -1 is -3. And those are your endpoints. So your final answer, I'm just going to throw it here in the middle. Your coordinates are -3 and -9. Okay. Number 25. Okay, so number 25, we're getting into the bisectors. So we are given the diagram off to the right. We have an angle TUV that has been bisected by ray UW. And what that does is that creates two interior angles. And the fact that UW is a bisector tells us a couple of things. The first thing it tells us is that angle TUW, which I've kind of marked as a 1 here. So angle TUW is equal to angle, measurement of angle TUW is equal to the measurement of angle WUV, because that's a perfect bisector. So it has cut that main angle TUV in half, but those are equal. The other thing we know is that the measurement of the large angle TUV is equal to the measurement of angle TUW plus the measurement of angle WUV. That actually is the definition of adjacent angles. So, but bisector obviously creates adjacent angles, they share a side. So now that we know that, we can use the value, the algebraic expressions that they've given us as the value for the two measurements to solve A, B, and C. So A wants us to solve for X. So the way we can do that is we put in the value, use this guy right here to create an equation. So angle TUW is measured as 2x minus 5, and that is equal to the measurement of WUV, which is 3x minus 22. Okay, so now we can subtract 2x from both sides. Basic algebra here equals 3 minus 2 is just x, that's just 1, minus 22. And now to isolate our variable, we have to get rid of that negative 22. So we add 22 to both sides. And we end up with x equals 17. So our value for x is 17. Once we've solved the value for x, we can then plug that value into the measurement for TUW. So the measurement of angle TUW is equal to 2x minus 5. So plug in that 17, 2 times 17 minus 5. 2 times 17 is 34, minus 5 is 29. So the measurement of angle TUW is 29 degrees. Now we can use the top equation that I've got right here, that the larger angle is equal to the sum of the interior angles. Excuse me. So the measurement of angle TUV is equal to what we just calculated, the measurement of angle TUW, which is 29 degrees. And because we know that the two interior angles are equal, then it's just 29 degrees plus 29 degrees. We don't have to plug in 17 into 3x minus 22 because we're going to get 29. So 29 plus 29 is, I think, 58. Yeah, 58. So the measurement of angle TUV is 58 degrees. Okay. Yep, no more over there. Now we get into the harder stuff. We're having to solve and prove. All right, so 27 tells us to find R if the midpoint of line segment RS is -1 and S equals 5. So there's a couple of things we need to start off with. First, we are given that the measurement, or excuse me, the midpoint of RS is bound at coordinate -1, and the coordinate at point S is equal to 5. So that's one of our endpoints. So that is given. So with that, we can, let's see, we're finding the endpoint. We have the midpoint and the S. So yeah, so in this case, we're using our, we need to state our midpoint formula. Midpoint equals, let me say this right, R plus S divided by 2. Why did I put a 2 there? Let's try this again. This is the midpoint formula. Now there's something else we're given that we need to make sure we state. We are also given that RS, I'm just going to make that an M. Point M is between R and S. Okay, hold on. No, sorry. Let me go back a second. I think I've got myself turned around a little bit. I apologize. First, we actually are given two different things. I just got them kind of in the wrong order. The first thing we need to state that we're given is the fact that M is the midpoint of line segment RS. Sorry, that is given. Then we use that, we start off with that given. We state the appropriate formula, which is the midpoint formula. Then we need to state that we actually have values for the midpoint and for one of the endpoints, point S. So we would state that M is equal to -1 and endpoint S is found at coordinate 5. This is also a given. Okay, now we have stated that M is the midpoint. We've given our midpoint formula. We've also stated that we have coordinates for the midpoint and one of the endpoints. So then we use substitution, which I'm going to go ahead and put over here. So we substitute the variables with their values. So using our midpoint formula, M, we could place a -1 on the left side, and then R is our unknown. But we do have S, which is 5, and then we're dividing that by 2. Now we're solving the algebra portion of this. So the first thing we have to do when we solve this is we have to do reverse order of operation, which means we undo the division first. So we divide both sides by 2 to get rid of this. Divide over 2. That is the multiplication property of equality. There's an equal sign for that. So that says that you can multiply or divide, because division is just multiplying times the reciprocal. As long as you do it to one side of the equation, you must do it to the other. And then it will still give you a correct answer that is valid mathematically. Okay, so that gives us -1, excuse me, not 2 times -1 is -2. And then those cancel out, R plus 5. Now for number 6, in order to isolate the variable R, we now must use the addition property of equality to subtract 5 from both sides. Because remember, subtraction is simply adding a negative, the opposite, or adding a negative number. So it still counts as addition. Addition property of equality. And then we can, from that, we can state that R is equal to -7. Now we write any answer to an algebraic expression with the variable first. So we say R is equal to -7, and that is the symmetrical property of equality. So symmetrical property of equality, remember, tells us that if -7 equals R, then R equals -7. So that helps us write it correctly. So the endpoint that we are solving is -7. All right, let's move on to number 29. So number 29 has us finding both endpoints. So the endpoint of MN, if the midpoint labeled P equals 2 and PN is 19. Let's start off with our given. So we are given that midpoint at point P is at coordinate 2, and line segment PN is equal to 19. So its length is 19. That is our given. All right, so because we are using a length to find the endpoints from the midpoint, we must use our distance formula. So let's state your distance formula, which tells us that PN, which is our length, is equal to the absolute value of P, which is 2, minus the coordinate at point N, which is the endpoint. And that's just going to represent both endpoints. You'll see that in a second when we define absolute value. This is the distance formula. That's your reason. Okay. So I almost did it right. Sorry. You write your distance formula just with variables. Sorry, P minus N. I was halfway there. Now we use substitution to plug in the values for each variable that we know. Now we know that Pn is equal to 19. And we know that point P, our midpoint, is 2. So that's substitution. We have just replaced the variables with their values or their coordinates and length in the case of the Pn. Now we need to define absolute value. So whenever we try to solve an equation with absolute value, you must create 2 separate equations, one with a negative length and one with a positive length in the case of our distance formula. So this is the definition of absolute value. Maybe, right? So that tells us that 19 is equal to 2 minus n, and negative 19 is equal to 2 minus n. All right, so now we solve. So for number 5, 19 equals 2 minus n. We must subtract 2 from both sides in both of these equations. In one case, so these become 0. So negative n is equal to 19 minus 2, which is 17, and negative 19 plus negative 2, which is negative 21. And that is, hopefully you figured it out, the addition property of equality. Hopefully this practice is starting to sink in. Now, we cannot leave those variables negative, remember? So we must then divide both negative n's in each equation by, oh goodness, by negative 1 to get rid of that, which means we also do it on the left side. And we are left with n equals negative 17 and a positive 21, because negative divided by a negative is positive. This is the multiplication property of equality. And then last but not least, we have our symmetrical property of equality, which puts them in the right order. And that states that n equals negative 17 and n equals 21. So there are our 2 endpoints to this formula. And then here is the proof of why each step works. All right, last one. We're almost there. All right, we are asked for number 31 to write a 2-column proof of the midpoint theorem. This one is, I believe, on page 98. It's 98 or 99. It's theorem 2.8.1. And it states that if M is the midpoint of line segment AB, then line segment AM is equal to 1/2 of line segment AB. So first, let's draw a diagram for our premises. There's a couple of steps to this problem. So A, B, and then right here, as close to the middle as I can get it, is M. There's our points. That's our diagram. So state the premise. The premise says that M is the midpoint of AB. It's given. And then we're asked to prove that AM is equal to 1/2 of line segment AB. All right, so that's what we're proving. So now D says list your statements and your reasons that prove this theorem. So first we start with our given. M is the midpoint of AB. given. Now, if we just stated that something is the midpoint of something else, we then need to state our midpoint formula because we're going to be using it. So the midpoint formula states that, I have to make sure I write this correctly. Am I using capital or lowercase? My poor brain is struggling tonight. Let's see here. The midpoint. Pause myself. Okay, it is lowercase. So m equals a plus b divided by 2. That is the midpoint formula. And then we state, what else are we given? Okay. Actually, hold on. I don't think that's what we need. I think I'm going in the wrong direction. I got myself confused working at the other problems. Let's go back to midpoint. Midpoint gives us, let's talk about what defining midpoint gives us. This is the definition of midpoint, not the formula. I'm sorry. It's so late. I'm trying. Knowing that M is the midpoint of AB means that line segment AM is equal to line segment MB. Okay, this makes sense. I was looking at my conclusion and I was like, wait a minute, that's not going to help me. AM is equal to MB, and M is between A and B. That's what midpoint tells us, two different things. That the line segments are the same length and that M is between A and B. So we also need to define what between means. So between, that when we add AM to MB, that equals the full length of AB. So this is the definition of between. Now we can substitute. So again, always look at what you're trying to prove. If you'll notice in your proof, you have line segment AM and you have line segment AB. There is no line segment MB in your final proof. So what you do is you take what you defined in point 2, the definition of midpoint, the AM equals MB. You then define between, saying that AM plus MB equals AB. And then you can replace that MB with AM because you just said they're the same thing in point 2. So the way you write that is the AM plus AM equals AB. And that is, really, you're just using substitution. Now we use the distributive property to add like variables, like terms together. And so instead of adding them together, we can just say that that's the same thing as 2 times AM, sort of like a reverse distribution property, distributive property. 5 is the distributive. 5 is 2. And now we can isolate AM by the multiplication property of equality. So 1/2, which is the reciprocal of 2, times 2 AM is equal to 1/2 times AB. That is the multiplication property of equality. And that's going to give us our final equation, because these cancel each other out, that AM is equal to 1/2 AB. All right, which when you go back to look at what you're trying to prove, AM equals 1/2 AB. I guess I could just call that Oh, shoot. Simplify, I mean, just so we put a name on it. So, and that's it. That's what they're asking for. So I will make another video that goes through the review guide for the quiz that's coming up. That will probably happen tomorrow morning since it's already 10:30. And just jot any notes, put a circle on anything that, even though you've watched the video, you're still totally confused about, and I will make sure that we sit down and talk about it when you get back in class. Otherwise, thank you very much, and I will see you when you get back to school. Bye-bye.